For our next series of videos, I opened a sample part called Area and Rest. And we're going to be concentrating on the Area 2D high-speed toolpaths. Again, our stock boundary, our material, all of that's been selected. Even if you go to the tool manager, you'll find that we already have 3 tools that are defined: a 3/16, a 3/8, and a 1/2 inch end mill. So let's dig into the toolpaths. We'll go to Toolpaths, 2D high speed, and we'll be doing area milling. Now again, these are the older toolpaths. They kept these here just to maintain continuity with previous versions of Mastercam. I don't expect that you'll be using the area a lot, but it does have its place, and it will give us a chance to get acquainted with the basic high-speed machining toolpath parameters. So we pick area, it'll prompt us for a name, and that name will come up to be the same as the name of the current file. I'm just going to OK that. So we have to pick our machining regions. And we're going to start with just this simple pocket over here. So to pick our region, we're going to be selecting off of the solid model. And I want to make sure that face is depressed. And we're going to pick this face right here. So by selecting that face, it gives us the entire boundary for our pocket. And we'll OK that. That's pretty much all we need with our chain selections. So we're going to say OK. You can see we're set to area mill. We have our machining region selected, and we're telling it to stay inside of that machining region. Now let's go grab a tool, and for this I'm going to grab the 1/2 inch flat end mill, and we'll add a comment. And I'll just say area mill standard pocket, and we'll take a look at our cut parameters. Now the area mill is pretty basic. You have a step over amount, which is defined as a percentage of the tool, and it shows here 15%. Now again, if I go look at my tools and I grab my 1/2 inch end mill and double click it, it'll open up the parameters, and if we check our finalized parameters here, it says that for milling, when you're taking a rough XY step, that it should calculate it based on 15% of the tool. It's also set that when it's taking a Z step, as in depth cuts, it's going to calculate that based on 200% of the diameter of the tool. A finish step in X and Y is set for 5%, and the finish step in Z is set for 200% to calculate the depth of cut. So all those are set. We'll finish that. Just wanted you to see where this value comes from. Now, even though we told it a 15% step over, which is 75 thousandths, it doesn't mean that every cut is going to be 75 thousandths. It's actually determined a minimum and a maximum range to work within. Down here we have stock to leave on the walls and the floor. I'll set the wall to 20 thousandths, and I'll set the stock on the floor to 0. So the whole point of taking a high-speed toolpath cut is to cut with the full length of the tool. So we're not going to be taking any depth cuts. We'll check our linking parameters. Our depth is set incrementally 0 thousandths from the face that I picked. That means it will be directly on that face. Top of stock is at absolute Z0. The feed plane is 100 thousandths above the top of stock, incrementally. The retract height is set as an absolute 250 thousandths above the top of the part. Now, how are we going to get into that pocket? Well, that's what transitions are for. To transition our way into this pocket, we're going to do a helix. Now, I usually like to set the radius for the helix to be slightly smaller than the radius of the tool that I'm using. You can make it any size you want, but if you make it bigger, then it will probably leave some boss standing up inside the middle of your helix. And then you have to come back and clean out that boss later. And that can be messy. So if I set this to be something less than the radius of the tool, I know that I'm going to get an overlap on the center point while still creating the maximum diameter that I can with that tool. When it's creating the helix, I want it to output 3D arc moves. Now that doesn't necessarily mean that you're going to get helical output in your program. That depends on your post processor. So when it's doing this helix entry move, if you're not getting G2s and G3s with IJK values, then it's probably something in your post processor. So without helical moves, you'll be getting a series of 3D points to spiral its way to the depth, which makes for a very large program. For my helical clearance height, this is where it's going to start to do the helix from. I want it to start from 30 thousandths above the top of the part. That way I don't spend a lot of time cutting air in a helical move. The plunge angle is set to a 2-degree slope, and that should be good. Here we have a preferred profile length. This would be if we were doing a profile ramp entry instead of a helical entry. Normally I would make this 3 to 4 times the diameter of the tool if there's room to do that. And then here's a value that says skip pockets if they're smaller than whatever this value is. Not going to be a problem for our part, so I'll just leave this the way it is. So with just those settings, we're going to say OK, and it'll calculate our toolpath. And we can see here, if I turn off my shading by hitting Alt-S, that it's doing a helix to the full depth, and then it's working its way out around the pocket. Feel free to take a look at that in Verify and see what it's doing.